Hi students, today I am going to give very good shortcut method to calculate bond order and comparison of bond lengths, magnetic properties like paramagnetic properties and diamagnetic properties. Actually this is very important question from chemical bonding. Now for solving this question just we need some calculation of number of electrons. On the basis of that directly we can say that what is the corresponding bond order and what is the bond length comparison and magnetic properties like paramagnetic or diamagnetic species. Okay, very simple. Almost within 15 seconds we can solve this question. Now let me give that shortcut method. First I am going to write number of electrons. One second. Number of electrons. Here I am taking number of electrons. Number of electrons I am taking from 1 to 8. 1 2 3 4 5 6 7 and 8 electrons. Okay, right. Again you start two separate systems. I am taking like 1 to 8 electron system and 8 to 20 electron system. Here I am taking 8 electrons, 9 electrons, 10 electrons, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 electrons. Okay, fine. 8 to 20 electrons. In first phase what we are taking 1 to 8 electrons. Here from 8 to 20 electrons, 8, 9, 10 and so on up to 20 electrons. Okay. So if you want to write the bond order without any molecular orbital diagram, actually what is the bond order calculation according to the molecular orbital diagram? Half into number of bonding electrons minus number of anti-bonding electrons. Here we don't want that formula and we don't want that lengthy molecular orbital diagram. Just on the basis of number of electrons, we are going to write what is the bond order and what about the magnetic properties, right? Here from 1 to 8 electrons, I am taking like this. 1 to 8 electrons. Now right side I am taking bond order. BO stands for bond order. Half 1 half 0, half 1 half 0, half 1 half 0, that's it. Okay, one second. Half 1 half 0, next half 1 half 0, half 1 half 0, half 1 half 0, that is the bond order. And from 8 to 20 electrons you better to start from 14 electrons. What is the bond order in 14 electron system? 3.0. Okay, 3.0 is the bond order, right? Next one, if you are moving towards right side, now for 15 electrons just decrease 0.5. From 14 either you are moving towards right side or moving towards left side, just to decrease 0.5 bond order. Here what is the bond order? 2.5 and then 2.0, again decrease 0.5. Then what is the bond order of 17 electrons? 1.5 and here 1.0, next 0.5, and what about 20 electrons bond order value? 0. Like that same thing here what we are taking from 3.0 just decrease 2.5, sorry 0.5, then what we are getting? 2.5 and here 2.0, then 1.5, next 1.0, next 0.5 and then here 0, that is the bond order value. Okay, now these are the bond orders with respect to the corresponding electrons, and you remember this point. Now very important point, all odd electron species, all odd electron species are paramagnetic. All odd electron species are paramagnetic. Okay, so whatever the odd electron species given, that should be what? Paramagnetic species. Next one, even electron species. Remember this point, even electron species. All even electron species. Again here two exceptions are there, that also I am going to give. One second. Yeah, odd, all even electron species are diamagnetic. All even electron species are diamagnetic except 10 electron and 16 electron species. Except 10 electron and 16 electron species. Now these two are what? Paramagnetic. So once again look at these 2 points. All odd electron species are paramagnetic. All even electron species are diamagnetic, but except only two cases, 10 electron species and 16 electron species. These two are said to be paramagnetic species. Okay, right. Let us start one example here. I am going to take these examples H2, next one H2 plus, H2 minus, hydrogen, next one with helium, helium 2 and helium plus 2, sorry, helium plus, only plus, helium, next I am taking here helium 2 plus, next one lithium Li2, Li2 plus, Li2 minus, hydrogen, helium, lithium, next one beryllium, Be2, Be2 plus, beryllium, next boron, B2, B2 plus, B2 minus, next with carbon, C2, C2 plus, C2 minus, even C2 2 minus. Okay, so I am going to remove these two statements. Why? Because I need some space. Now once again remember these 2 points. All odd electron species are paramagnetic. All even electron species are diamagnetic except these two. 10 electron species and 16 electron species. Right. After C2 I am taking nitrogen N2, N2 plus, N2 minus, N2 2 minus. Okay. Next one O2, O2 plus, O2 minus, O2 2 minus. Next one F2 Ne2, F2 and Ne2. Next even we are taking NO, next one NO plus, NO and NO plus. These are the given species, right? Now let us start writing bond order values. So what is the bond order value for H2? H2 how many electrons present? 2 electrons. What is the bond order? 1. It is paramagnetic species or diamagnetic species. Once 2 electrons are present, that should be taken as what? Diamagnetic species. Okay. Next one H2 plus. H2 plus contains how many electrons? 1 electron. What is the bond order value? Half. Half or 0.5. Now this one electron species. Odd electron species. Paramagnetic or diamagnetic. This one paramagnetic species. Clear. H2 minus contains how many electrons? 3 electrons. What is the bond order value? Half. Because of the presence of 3 electrons, again this one paramagnetic species. Okay, right. And He2, hydrogen, helium. Total how many electrons present? 4 electrons are there. 4 electrons. What is the bond order value? 0. Bond order value 0, nothing but that molecule is not existing, right? He2 plus, number of electrons? 3 electrons. What is the bond order value? Half. 3 electrons means paramagnetic or diamagnetic. This one paramagnetic species, right? Come to Li2. Li2. In case of Li2, what is the atomic number of lithium? Hydrogen, helium, lithium. Atomic number 3. 3 twos are 6 electrons. 6 electrons. What is the bond order value? 1. 6 electrons means diamagnetic or paramagnetic. Diamagnetic species. Okay. Li2 plus 5 electrons. What is the bond order value? Half. Paramagnetic or diamagnetic? All odd electron species are paramagnetic species. What is the magnetic behavior? Paramagnetic. Li2 minus, hydrogen, helium, lithium. 3 twos are 6 electrons plus 1. Because of the presence of negative charge, extra 1 electron, 7 electrons. What is the bond order value? Half. Because of the presence of 7 electrons, what is the magnetic behavior? That is paramagnetic species. Okay, right. Next one Be2, hydrogen, helium, lithium, beryllium. What is the atomic number of beryllium? 4. 4 2 jar, how many electrons? 8 electrons. 8 electrons means what is the bond order value? 0. Next one Be2 plus, 0 nothing but your molecule is not existing. If there is no unpaired electrons, simply that species is said to be diamagnetic species. Be2 plus, Be2 plus contains how many electrons? 7 electrons. What is the bond order value? Half. 7 electrons means what is the magnetic behavior? Paramagnetic behavior. Okay, right. Next one B2. What is atomic number of boron? 5. 5 twos are how many electrons? 10 electrons. For 10 electron species, what is the bond order value? 1.0. Paramagnetic or diamagnetic? Now it contains even number of electrons. Very important example. Already I have given two important points. What is the first point? All Odd electron species are paramagnetic. All even electron species are diamagnetic except 10 electron species and 16 electron species. 10 electron species paramagnetic. Very important point. Next one. B2 plus. How many electrons? 9 electrons. 0.5 is the bond order. Okay. 0.5 or half. And what is the magnetic behavior? Again, paramagnetic species. Why? Because B2 plus is 9 electron species, odd electron species. Okay. B2 minus. How many electrons present? 11 electrons. What is the bond order value? 1.5. Paramagnetic or diamagnetic? Again, this one paramagnetic species because of odd electron species. Next one, C2. What is carbon atomic number? 6. 6 2s are 12 electrons. What is bond order value? 2.0. Okay. Next one. What is the magnetic behavior? Because of the presence of even number of electrons, that should be taken as what? Diamagnetic species. Right. C2 plus. From 12 electrons, just to remove 1 electron, then you are getting 11 electrons. What is the bond order value? 1.5. 1.5 is the bond order. And what is the magnetic behavior? Odd number of electrons, that should be what? Paramagnetic species, right? C2 minus 12 plus 1 electron, 13 electrons. What is the bond order value? 2.5. 2.5 is the bond order. 13 electrons means paramagnetic species. Paramagnetic species, okay. C2 2 minus. How many electrons? 14 electrons. What is the bond order value? 3.0. What is the magnetic behavior? Diamagnetic species. Why? Because 14 electrons nothing but even electron species, diamagnetic. And come to N2. Okay, I am taking one more page here. N2. Yeah, one second, one second. So here I am taking N2. Next one, N2 plus, N2 minus, N2 plus, N2 minus. Next one, N2 2 minus. Okay, next. After nitrogen I am taking oxygen. O2, O2 plus, O2 minus, O2 2 minus. Oxygen. Next one, F2, Ne2, Ne2. Next I am taking NO and NO plus, and even we can take CO, right? Carbon and oxygen. Carbon and oxygen equal size. Yeah, carbon monoxide. Now you start from N2. What is the bond order for N2? Now in case of N2, number of electrons 14 electrons. 14 electrons means what is the bond order value? 3.0. Diamagnetic species or paramagnetic species? Diamagnetic species. N2 plus. N2 plus means how many electrons? 13 electrons. What is the bond order value? 2.5. 13 electrons means paramagnetic species, odd number of electrons. Okay, right? Paramagnetic species, clear. Next, N2 minus. N2 minus means how many electrons? 15 electrons. For 15 electrons, what is the bond order value? 2.5. Because of the presence of 15 electrons, what is the magnetic behavior? Paramagnetic. Next one, N2 2 minus. N2 2 minus, very important example. N2 2 minus, 16 electrons are there. In case of 16 electron species, what is the bond order value? 2.0. 2.0. And what is the speciality of this molecule? Now because of the presence of 16 electrons, that should be paramagnetic but not diamagnetic. Don't get confusion in case of N2 minus. Once again I am going to repeat the same point. All odd electron species are paramagnetic. All even electron species are diamagnetic except 10 electron species and 16 electron species. 10 electron species paramagnetic, 16 electron species paramagnetic. Clear? Next one, O2. How many electrons present? 16 electrons. What is the bond order value? 2.0. And what is the magnetic behavior? Your magnetic behavior is paramagnetic species. Why? Because already we know that all 16 electron species are paramagnetic in nature. So in general, in chemical bonding, they are giving diatomic molecules up to atomic number 10. Okay, right. Next one, O2 plus. O2 plus, how many electrons? 16 minus 1, 15 electrons. 15 electrons means what is the bond order value? 2.5. Okay, bond order value 2.5. And what is the magnetic behavior? Paramagnetic species. O2 minus. O2 minus, how many electrons? 17 electrons. So in case of 17 electrons, what is the bond order value? 1.5. 1.5 is the bond order because of 17 electrons. Now that is also paramagnetic species. O2 2 minus, how many electrons? Oxygen nothing but 8 atomic number, 8 2s are 16. 16 plus 2, 18 electrons. With 18 electrons, what is the bond order value? Here, 1.0 is the bond order, right? 1.0. And what is the magnetic behavior? Diamagnetic. And come to fluorine. Now here fluorine, how many electrons? Oxygen, fluorine. 9. 9 2s are 18 electrons. 18 electrons nothing but what is the bond order value? Again you check here, 18. 1.0. Okay. 1.0 is the bond order. And what is the magnetic behavior? Diamagnetic species. Ne2, 20 electrons. 0 bond order. Diamagnetic. Sorry, there is no unpaired electron. Simply that is diamagnetic species, right? NO. What is nitrogen atomic number? 7. And what is oxygen atomic number? 8. 7 plus 8, 15 electrons. For 15 electrons, what is the bond order value? 2.5. 2.5. And what is the magnetic behavior? Paramagnetic species. Clear? Next one, NO plus. From 15 electrons, just to remove 1 electron, then you are getting 14 electrons. 14 electrons nothing but what is the bond order value? 3.0. So for 14 electrons, it is paramagnetic species or diamagnetic species? Yes, it is 14 electrons, diamagnetic species. After completing all these examples, now here you don't apply any shortcut method. There is some different behavior of, for example, if you are taking CO and CO plus, there is no problem with CO. Okay, what is the bond order of CO? 3.0 because of the presence of 14 electrons. But this is the exceptional behavior. Why this one shows exceptional behavior? Very clear explanation we will see in chemical bonding, right? CO molecule, its bond order value is exceptionally 3.5. Very important example. Most of the time we are going to forget this CO plus. Now once CO plus is given, exceptionally what is the bond order of CO plus? 3.5 is the bond order. Okay, this is the story about bond order calculation and magnetic behavior in terms of paramagnetic species and diamagnetic species. Once again I am going to tell same point. Now this is very important example. CO plus bond order value is how much? 3.5. 3.5 is the bond order. Okay, right. Next one, here if you want to compare the bond lengths, here bond length is inversely proportional to bond order. Very important, bond length is inversely proportional to bond order. For example, if they are giving O2, O2 plus, O2 minus and O2, 2 minus. First I am going to write the bond order. What is the bond order of O2? 2.0, 16 electron species. And O2 plus means 15 electrons. What is the bond order value? 2.5. Next one, O2 minus, how many electrons? 16 plus 1, 17 electrons. Okay, 17 electron species nothing but O2 minus 16 plus 1, yes, 17 electrons. What is the bond order value for 17 electrons? 1.5. Yes, 1.5 is the bond order. Next one, here 18 electrons, 1.0 is the bond order, right? So first how to write the bond order? Here first I am giving priority for O2 plus greater than, next O2 greater than, O2 minus greater than, O2 2 minus. Next, if you want to write bond length, this comparison very important. Once you go and check PYQs, you will get lot of questions from this bond order and bond length comparison. Next, I am going to compare bond length. Okay, what is the relation between bond length and bond order? Bond length is inversely proportional to bond order. Then what is the bond length? O2 2 minus greater than, O2 minus greater than, O2 greater than, O2 plus. That is the bond length. Okay, this is very good shortcut method in the calculation of bond order, magnetic behavior, and in the comparison of bond length and bond order. Okay, thank you.